All right, here's a quick walkthrough for the review sheet on circles. So this exterior angle P would be equal to half of the arcs subtracted from each other. And this one's just a quick and easy 70 minus 20 divided by 2, which would be 25 degrees. The next question is a little bit of a deeper question, looking for the arc when we know the interior angle. So in this one, it's kind of backwards. They've actually told us the answer. What they want to know is, what was the question? What two arcs would give us an average of 34? There's a few ways to work this question out. One way is by using the formula. The 34 degrees has to equal the average of the two arcs. So in this picture right here, if we use the formula, it'd be 34 degrees must equal half of 50 plus some unknown arc. And a quick way to solve that equation could be to distribute the half into the parentheses, but another way to do that is to multiply both sides of the equation by 2, which would quickly get you 68 equals 50 plus x. Subtracting 50 away from both sides would get you to the answer that x is equal to 18 degrees. And there, of course, there are other ways to figure this out too. One way is just to guess and check. Try to pick numbers that could be for x. So when you take 50 and that number that you're guessing, do they average to be 34 or not? Question number 3 is impossible to do unless you use the semicircles that are in the picture, but you're not told that they're semicircles. They just tell you that there's a diameter in the picture. So we've got 180 degrees up top, 180 degrees down below. Putting in the information they told us about the picture, that this arc would be worth 40 degrees here. We'd also know that it's 40 degrees here because of the way the picture is drawn. And that becomes a necessary number to know, since you are trying to figure out how big the inscribed angle DAY is. So as mentioned in class, those inscribed angles are like mouths that are chewing on the circle. So this angle here, angle DAY, is chewing on part of the circle. So look at where the fangs are, and you can see that it's trying to eat all of those degrees that are on that part of the picture. So again, it's chewing on this part of the circle. And the green part there in the circle is 180 degrees plus another 40 degrees. So 220 degrees there, which makes the inside not 220, but it makes that interior angle 110 degrees. Moving ahead to question number 4. They're telling us that these arcs are the same. They're both 130 degrees. Impossible to figure this question out unless you use the fact that there's 360 degrees all the way around on a circle. So far we've got 130 and 130. So altogether that's 260 that we've got. So what's left over for this segment UK, or this arc UK, would be 360 take away 260, or 100 degrees. And if it's 100 degrees on the circle, the inscribed angle would be half as much. So choice 1. For question number 5, impossible to do this question again unless you actually keep your eye open to 360 degrees being a full circle. The givens are that this arc AB is 132 degrees and this arc CB is 46. To be able to find angle P, we need to find the arcs that the angle on the outside is splitting into the circle on. So to do that, we need to find out that large arc A, capital A. All three angles have to add up to, all three angle measurements or degree measurements have to add up to 360. So A would have to be 182 to complete the 360-degree round trip. And then using those numbers into the formula, it would be 182, take away 46, divided by 2, which would be worth 68 degrees for angle P. And then question number 6. Again, it's using the fact that there's a total of 360 degrees all the way around. If we have 220, to complete the round trip of 360, we would need this red arc to be worth 140 degrees, again, to make 360. And then, since we're looking for the exterior angle, it would be 220, take away the 140, divided by 2, which would be half of 80. So angle A would be worth 40 degrees. Okay, moving ahead into the last couple pages. For question number 7, I've already written down the given information, and they're looking for angle P as the very first angle that they're asking for. So keeping your attention to the type of angle that it is, it's an exterior angle. So it would be following the formula half the arcs added together, or arcs subtracted from each other. And the one arc we know is 130 degrees. The arc that we still need is the smaller arc that's inside that angle. And a way to figure that out is to use, one way to figure that out is to use the 50 that they already gave us. The 50 is an inscribed angle, and that 50 is chewing on this part of the circle BC, of this arc. So since that's 50 degrees there, the arc would have to be twice as much, or 100 degrees. Keeping your eyes open for 180 degrees is important. This is a semicircle right here from A to B. So from A to C, it must be 80, so that it completes the 180 degrees for the half circle. And that would be one way to find that missing arc measurement of 80. So we get half of 50, so angle P must be worth 25. I'm going to write it right into the picture. So angle P is 25 degrees, and they're asking me for a couple more things. They're asking me for BEC. I'm going to change colors here. BEC is this angle here. To find that angle, I'm noticing that it's an interior angle, so it would be half as big as these arcs added together, or just halfway between 100 and 130. If you wrote it out as a formula, it would be 1/2 of 130 plus 100, which would be half of 230, which would be 115 for angle E. And then finally, they're asking me for angle PCA. PCA, changing the color one more time to red. PCA is this angle here. And taking a few minutes to take a look at this might be necessary, but after looking at it enough, I realized that if you could locate this angle here, then this angle here would be the rest of the straight line. These two angles are linear angles, so if I could find this angle here, I'd be in business because I could subtract away from 180 to get that. So that's 130 degrees on the circle here. So on the inscribed angle there, it will be half as much, or 65, which makes this angle here 115 degrees, since together they add up to 180 degrees.